Do you see presentation? Everything is good?
Yeah.
Yes?
Yes.
Thank you. Hi everyone. It's a pleasure to me that you are here and I'm here. I don't see you, but I know that you are here. And today we continue and complete a short excursion into finance, because a lot of financial terms really are very essential for our course. At the last lesson, at the previous lesson, we studied a three possibility which investor has to get a profit. But profit $1, $10, $100, it's a not efficient indicator. And today we learned next term, a return. It is very close to profit, but there are a difference. In finance, a return is a profit on investment, but expressed as a proportion of the original investment. You understand that it is different, because, for example, my initial investment was $10, but at the end of period I get $50. It's okay, yes, because I had 10, but now I have $50, for example. But if at the end of period I had 45, but at the end I had 50, it is a difference. So, but if we measure this in as a proportion, so it is more efficiency indicator. So it's return. And please remember that this formula may be written as a difference between investment and the end of period, at the moment T capital, and investment in the initial moment, and divided by value amount at the end of period. But we can write this and as a difference between proportion VT divided by V0 and -1. So it's return. And I have example. If you hold 100 shares with a starting price of 10, sorry, then the starting value at the end of period, your investment, it is 100 multiplied 10, 1,000. So it is, no, for example, you paid these shares for 100 or $1,000. If you then collect this sum 0.5 per every share as a dividend, so, and the ending share price and the ending share price, for example, is 9.80. Why this price? Because you know that the price of stock is very fluctuated, and this price can be more than initial price 10 or less than initial price. So at the end of the period, you have you have 50 in cash because its product, the price for dividends multiplied 10, and 100 and plus money for your stocks. 100 multiplied 9.80. So the total sum 980 in shares. And if we find sum 980 plus 50, it will be 1030. So the change in value only profit. It is a difference. 130 minus 1030 minus 1000, and it is only 30. But return, it is proportion. 30 divided by 1000, because initial investment were 1000. And we have this return 3%. But the next question, is it a good return? Maybe you can answer this question. Who would like to answer? Sophia, what do you think about this? Is it a good return 3%?
I'm not sure about this, but I think that it might be better. It's not the best return, I think.
But say me please, maybe you compare, yes? But you compare with returns which you know for what period? 3% for what period? For 1 year maybe, yes?
Yeah.
In this problem, we can't we don't know this period, and it's problem. So so we should to point this period, and to compare returns over different time periods. We should to choose equal period, and to use it is useful to convert each return into annual equivalent rate of return. So we have return, but if it is annual, it will be rate of return. This conversation process is called analyzation. Understand the difference? So, sorry. So we have the follow terms: profit, return, and profit, yes, return, and rate of return. How we can find rate of return? There are two approaches, two assumptions. The first approach and assumption, it is rate of return without any reinvestment. So it is only, we only divide the return by the amount of periods, on all divide period of length t. And again, for example, yes, now I'll read this example, but shortly, it only this formula, using this formula. So it is if we have 20% for 5 years, we can only divide 20% by 5 years. And in this, for example, $20,000 returned on initial investment on $100,000. So a return, it is 20% because it is 20 divided by and expressed in percents. But if this return will be for 5 years, we have divided by 5. Or we can find for 1 year in this way. So it's Formula 1. But there are another approaches, another assumption. It is with reinvestment. What is this? Now you know already this formula. It is formula of compounding percent. Yes, you know this formula. It is the investment. It is initial investment. It is the value of investment at the end of period T capital, and R little. It is rate of return. Is this formula we can find this rate of return. Yes, this profit VT divided by V0, it's easy. It is easy. So we have this formula, but maybe you remember that at the this slide from this formula we can find this proportion VT divided by V0. It is R capital plus 1. Yes, R capital plus 1. So instead of this, we write R capital, and this is the same. So we have the formula 2. It is formula which connect R little and R capital. So the formula which links rate and rate of return for period length T. And for example, if we remember the last example and where we divided 20% by 5 years, and it will be 4%. We used in this example approach without any reinvestment. But if in this we use another approach, it will be 3.7%. 0.02, it's from this. R capital, you see. And we have another value rate of return. So it's important. And from this formula 2, we can express R capital through R little, and it will be formula 3, where we express return to a rate of return.
Excuse me, may I have a question?
Yes.
So it's a question about this formula R plus 1. On the previous slide, it's R plus 1 to the... So previously we had the equation that had formula VT divided by V0 minus 1, and now we like substituted it to to this formula, and we have now +1. Am I missing something here?
You speak about this slide.
Yes, yes.
So this formula, you know, yes, you agree with this formula.
Yes.
This formula.
Mm-hmm.
It's from this formula.
Yes, so you said we substitute this
yeah, 1 plus
proportion.
r to the power 10 equals Vt divided by V0, yes?
Yes.
After that, we can square. Yes, yes, yes. Yeah, this is all right.
No, I mean after this, yes, this formula where we have the proportion Vt divided by V0, and you move it to the to even the previous slides, and they had this formula of rate. Oh, okay, okay. I think I got it. Yes.
Yes.
Yes, thank you. I got it.
You got it. But there are another another approach. Maybe its consequence. It is logarithmic or continuously compounding return. The definition of the logarithmic or compounding return, it is not only proportion, but logarithm of this proportion. And rate of return, this logarithm divided by t capital. And maybe you think that it's rather strange, but it's very natural because we can find this. We can find formula 5 not only from 4, but and as solution of this equation. So this equation, it is the formula of the compounding return. Yes, V at the end of period equals V capital at the end of period multiplied exponential to the power RT capital. But if you find from this formula R little, it will be so exponential will be Vt divided by V0, and after that we can find ln, and we get the formula 5. So formula 5 we can get from formula 4 and from a solution of the equation of compounded return. And you see that it will be useful in a lot of problems and in our first two. So please remember this formula. I mean 5. Formula 5, and we can see comparison of ordinary returns and logarithmic returns for initial investment of $100. So again, our initial investment $100, $100, and for any cases, initial investment of $100. And some that final investment will be, and different cases you see, 0, 50, 99, and so on. We can find only profit. So profit, it is difference between final investment and initial. So we have this amount with minus 50 minus 100 with minus 99 with 100 with minus 1. This is 0, and this value you see with plus 101 minus 100, 150, and so on. Ordinary return. Ordinary return, it is a proportion between between profit or loss and initial, and express it in percent. So 100 we divided by 100, it is with minus 1, minus 1 in percent will be minus 100%. This the same, minus 50 divided by 100, it is 1 second, and with minus, and in percent minus 50. Yes, and so on. 1 divided by 100 and expressed in percent will be minus 1%. And in this case it is 0, and in the next cases it is its value positive. But if we find this as a logarithm, this it will be infinity with minus. But in the next cases we find using this formula. So we find this proportion. After this we find logarithm, and it will be this value. After that, we move to the next term. It is very important term, cash flow. Cash flow. What is cash flow? Cash flow, it is a time series. For example, it is what you spend and have for a day. For example, your mom give you 100 hryvnia. It is C sub-zero. After that, you spend 10 hryvnia. After that, you spent 15 hryvnia. After that, you met your friend, and that meant that friend gave you 15 hryvnia. So it's with plus. So this consequence of different values with plus and minus, it's cash flow. It's easy maybe, but we are interested in perpetuity and annuity. What is this? Perpetuity, it is a stream of equal cash payments, equal. So C0, C1, C2, Cn, it is all equal value, and at regular intervals, and that continues forever. So we don't, we haven't end, finish, Cn, and so on. In life, it is, for example, consoles preferred stocks. And if C1, let this all value will be equal, so C1 equals C2 equals Cn, and for example it's A capital, and the problem is what is.
Question.
Mhm.
You said as an example, controls and preferred stocks. What are controls?
It is as a dividends.
Mm-hmm. And about preferred stocks, you mean, can you give an example of those? How does this work with the preferred stocks? This cash flow, this perpetuity cash flow.
Yes, I understand. It is no, it is not a very important example. So it is for us is important that only so it is this payment for infinity. Another example, it is if you have account in the bank, and every year you get a percent, and you get this percent equal, and every year.
Okay, so here we have that all cash flows are equal in value?
Yes.
Okay, thank
equal
you.
in value. And problem is what is value we should have that this operation can be true. What is in other words, what is value I can put at the bank account if this bank pay R%, that I have possibility every year get this value A. First year A, the second A, and so on. We can get this formula. It's very easy, but I don't write it this, but I can explain. You have eight. You have a present value PV. PV it is present value. Present value at the end of period, and if you put it in your bank account at the end of period, at the end of 1 year, it will be PV multiplied 1 plus this R, multiplied R. So, and you should subtract A, and the result may be PV. And from this equation, you should find this formula. If you now have possibility to take a paper and write, you can. Please write this because I haven't this possibility. Please write PV multiplied 1 plus R little minus R capital equals PV, and find from this equation PV. And I am waiting. Tia, did you get results?
I'd like to ask you to repeat this, please. So I'd like to share my screen and try to write it on the board.
I get it.
Because
so write please PV.
oh, okay. Can you please give me a permission to share my screen? I want to share the screen.
I can. Just a moment.
Okay, thank you. Can you please repeat?
PV.
Yeah.
Yes, multiplied and in bracket 1 plus R. And bracket close. Minus A capital. No, minus A capital.
Okay.
Equals PV. Because it is PV, it's at the end of period, it is at the beginning of the period, it is at the end of period, and we should give this value. And
this A?
As A, yes. In this problem, we should every year give you, no, if I bank, I should give you, but if you client, you should get A. And I am from bank, speak. So you, for example, Sophia, give in my bank PV, present value. At the end of period, it will be this sum, but I should give to Sophia this value. It's my obligation. I obligated that every year I will give you a capital to infinity. But to order that it will be possible, the sum of what leaves will be PV, because in this case, at the second year, it will be the same. This PV, it will be at the end of period, it will be at the start of period, it will be at the end of period, and so on. So A will be...
Okay, so this return rate, is this the annual return rate?
No, it's not true formula. PV multiplied to 1.
Okay, let me...
Maybe.
Okay. So PV 1 plus R minus PV, and A equals PV 1 plus R minus 1, yeah?
But in this problem, I should to find PV.
Okay. I
A.
get you. Okay.
What is PV?
Yeah.
Present value.
PV equals... yeah, okay.
Oh.
So PV, the present value is the money that I should pay to bank, yeah?
Yes.
Okay.
Put at the bank. And
Okay.
sign this agreement.